Hello, this is the second of maybe three solutions to current sailing problems that we're working out with qtVlm. And the first one we did was we found course made good and speed made good in the presence of current. So we know if we do nothing, we're going to get set. Now the question is, we want to choose the course we want to go. Like right now we say we want to go 0650. We know there's current. The current is, I cranked up the current a little bit here. The current's 2.0 knots in direction 300. We want to make good 060, and our speed, our only speed we have, that maximum we can do under power, say, is 6.5 knots. And so the question is, what course do we steer to make good this in that presence of that current? And then what will be our final speed made good along the course we want to go? So that's the exercise we're doing. And we'll do, let's see, pathways, edit a pathway. Okay, so we're going to do it with this pathway tool again. Maybe a little bit different. Let's see, enter a pathway, let's create a pathway, and let's call it, let's say, course to steer. We'll make this one red, say. Okay, red. It's not going to be closed. Start from the first mark. Okay, so I think that's it. Now we say append. That means do it, make them, decide where they're going to go. And again, when solving these kind of vector problems with the current, it does not matter where you do it on the chart. You could do it, well, you can do this on a blank piece of paper with a protractor and a ruler and dividers. You don't need a fancy tool like this, but when you got a tool like this is a quick way to do it. All right, so what do we've got here? Okay, the way this exercise starts is you mainly got to get your course in there where you want to go. So let's say we want to go 060. That's about there. So let me get, and I don't care how long it is on this exercise. I just want to be sure I've got 060 as best that's good. Can't argue with that. Now, the next thing is the current is flowing 2 knots in that direction, 300. But to correct for the current, we know we got to point into the current. So really I need to drive, my next line is going to be into the current. So it's really 300 minus 180. So I want to go in direction 120 now. So this next point I make is going to be in direction 120. 120, and it's going to be the length of the current, 2.0 at 120. Oh, look at that, perfect. Okay, so that represents the current's going that way, but I'm going in that way. Now, the next thing is I can only go 6.5 knots. So right now, I just take my last point, it's going to be down here somewhere, and that's got to be 6.5 long. Oh wait, is that my speed? Yeah, my speed under power, say, is 6.5. So that's about like that. Let me just zoom in a little bit to get a little, whoops, I didn't, delete. Yes, okay. This is the one I want. Let me just see if, oh, okay, I better use the arrow. Whoops. The arrows and the plus key. If I kick the board, it's going to get bigger. Okay, so there we go. So this one I want to be 6.5, and I've got to be 6.5 on this line, right about, looks like it's right there, 6.5. And that's it. Now I'm going to hit the escape key. I'm done, and I can now zoom in here if I need to. Yeah, that's pretty good. So this line ought to be 6.5. Let's check our work here. That's 6.5. This should be a 2.0. And this we don't care how long it is, but that's what we're going to after. We do care that it's in 060 though. 060. Oh, perfect. Good job. All right, but now, so here's what the situation is. Now, let's reverse this. I'm going to go in here, edit the pathway, and reverse it, just so I don't have to do math in my head. So here's the answer, and the direction that I get is 075.7. 075.7, and here we have our Star Pilot computer solution, 075.5. Okay, that's good. So this is the way we're going to go. This is the heading we're going to take. So here's the way you think through this. And we're starting, everything starts right here. And so we start here, and in 1 hour, this is my 6.5. In 1 hour, I'm going to go 6.5 miles up to here. Now, in that same hour, all this water in this part of the world is going to go 2.0 miles in this direction. That's the set of the drift, set of the current. I mean, the drift of the current in that direction. So that means I'm going to end up here. I go 1 hour through the water goes up here, so I'm 1 hour, I'm right up here. So what does that mean my course and speed made good is? Well, my course is this guy. Now, which way is he pointing? Probably the wrong way. Let me reverse him again. Edit pathway. Let me go back to where we were. So the direction, oh no, that's 60. Oh, come on. Okay, that's 60. We know that. That's the way we wanted to go in the first place. But now the speed made good is going to be the length of this vector from here up to here. And we could do that maybe. See, I made this one longer than we need to. Let me just bring him up and drop him right on top here. Yeah, that looks pretty good. Yeah, well, I moved that one a little bit. But anyway, there's the answer here, and that says 5.2. 5.2, and what do we have here? We do it with a big calculator, computer actually, 5.26. Okay, so that's what the answer is in this type of problem. So if we want to make good 060, we can go 6.5 knots. The current's 2 knots in this direction. So we point into the current. You always point into the current. So 1 hour I go here, 1 hour the water goes here, and I made it here. So I'm going to progress. My boat's going to be pointed in this direction, right? In this direction the whole time, but it's going to crab up this line here, making good a speed of about 5.2, 5.3, something like that. That is that solution. So remember, when you do these with a computer or with a piece of paper, the first thing is just draw the line in the direction you want to go. Somewhere on that line, anywhere, it does not matter, draw a line in the direction into the current, the length of the current, and from there swing an arc of your boat speed back to where it intersects here, and that's your answer. So that's the course to steer to correct for current.